Hey, welcome to the very first interview for 2015 on iTWire.com. With me I have Olivier Bilodeau, who is a malware researcher with internet security company ESET. Welcome and thank you for joining us.
Thanks.
Now, you're in Australia visiting the ESET local offices. I'm here in the headquarters in Neutral Bay. And you're on the way to the Linux.conf.au conference being held this year in New Zealand. So I was wondering, what will you be talking about at the conference?
I will be talking about advanced Linux server-side threats, how they can be detected, and what to do about them, how to react to them.
Yeah, I mean, previously people thought Linux was virus-free, but clearly it's not the case.
Yeah, it can happen, and the threats are really different than what we saw in the past, but yeah, definitely, it's a reality now.
Now, before we get into some more details about what else we're going to be talking about in this interview, tell me a little bit about what got you into the malware research and the security business at ESET. I mean, you were telling me before you had a bit of an interest in IT, and you even had a teaching background.
Yes. I worked as a system administrator. I had some work also in networking. Then this kind of blended together as I became an open source software developer for a network access control software, which is kind of security and network together.
Yeah.
But then someone presented me with reverse engineering challenges, and I realized that it was really a hard field, hard work. And I was challenged by it and really intrigued. And so I decided to change from developer to malware researchers because I was really intrigued and interested by the challenges that it had, and also there's a bit maybe of doing the good thing, you know, trying to prevent the bad malware to spread to you know, the innocent people using computers.
With great power comes great responsibility, as they say for Spider-Man. But no, we need the good guys because otherwise the bad guys will win. So thank you for that. Now, tell us what's some of the malware that you've been researching over the past couple of years.
So, by chance, I guess, I've been working a lot with Linux malware lately. Being it binaries or scripting languages, but still affecting Linux and Unix systems. I've worked also with advanced persistent threats targeting the Asian countries in the past. And a few of the more generic Windows malware.
Now, one of the things you've been working on is Windigo. When did Windigo emerge, and what triggered you and your fellow researchers at ESET to realize that this was a big enterprise threat?
So at first we were working with a threat we called CDORC. This was in 2013, spring 2013. And this attracted a lot of new collaboration because we did this original work with security, and it turns out that we got other malware, if you want, samples we call them, related to these threats, and at some point we were able to make a link between them. They were using the same cryptographic, obfuscation technique, not really encryption per se, but similar. And this triggers us to look at it a little bit more. So we set up a server to gather some of the infection statistics. The way the malware was built, we were able to do that. And we realized that during a few hours, we got 7,000 infected servers. So 7,000 might not seem big if you compare with the millions of PCs participating in a botnet, but when it's servers, they are facing potentially, millions of computers. So for us, this figure was really big, and right away triggered an interest to understand more what was going on and to analyze it further. So,
clearly. I've got some stats here that say that Operation Windigo is a server-side Linux malware. Now, it's infected 25,000 servers, so we're talking about lots of different servers being affected, and it's affecting 500,000 Windows end users daily. So how was Windigo built? How does it work, and how does it infect servers?
So it's a very complex component. We have a diagram in our report which is every time we present it in conferences, people are overloaded because there's too much information. But I'll try to make it simple.
Sure.
So the basis of this threat is the piece of malware called Ebery, which is an SSH backdoor. So OpenSSH is the software. And this is on all the 25,000 servers. It's the main component. This gives the criminals access to the terminal of the server, and so they can repurpose the server to their bidding.
Yeah.
Then on top of that, what they will deploy, depending on the circumstances and on what the server has access to, they can deploy CDOR, which is an HTTP server backdoor. So kind of the web pages you usually visit are hosted by an HTTP server. And so CDOR is another piece that is installed if the server is interesting enough, if the server is already serving web content. And this component will redirect the users to exploit kits or to casino spam, adult spam, not spam, but affiliate ads to do sign up and make money on the signups. So casino, adult, and dating sites. This is CDOR. And the last component for the server part of the operation is CalfBot. CalfBot is a little Perl spam daemon which just sends spam as fast as it can. And this can be installed even if the server is not, if the compromise is not system super user, so root in Linux terms, compromise. So even if the server is compromised with only username and password,
this nasty thing can still be installed.
Can still be installed and be effective. And so this is installed when the IP, the reputation of the IP address of the server is good, and so that the spam can be sent to Gmail, Yahoo, Hotmail, and all that.
Without being blocked by those services.
Exactly. And the last, if you want, piece is when the users are sent to exploit kits by the CDOR component I mentioned earlier. If they are exploited successfully, it will install a Windows malware, which is called Glupteba, which is another generic proxy system, but which is used again to send more spam as part of this operation. And the content of the spam is more links to adult sites, dating sites, and casino. So this whole thing exists only to make money to the criminals operating it, and make money by, like, if you want, fraud of the affiliate programs of these type of sites.
Yeah, it's a real web of sin. That's
yes.
You know, it's incredible. So how is this different from traditional server-side threats?
So what we used to read on or see with the server-side threats is doing direct damage or leveraging the resources for distributed denial of service, so DDoS attack. Direct damage being I wipe all the files on the server because I'm targeting your company and want to do damage on it.
Like with Sony, for example, they just wiped everything.
Exactly.
Yeah, but this is more of this particular one's more of a parasitic threat. Doesn't want to eliminate the host.
No,
it wants to suck
in
off
fact,
it. Yeah.
In fact, it wants to leverage the good reputation of the host. The more legitimate sites there is on the host, the better it is for them. So, parasite is a very good analogy of what's happening with this threat.
And it shows how these malware guys are becoming ever more sophisticated. It's not just seek and destroy; it's seek and exploit.
Yeah, and it's more kind of a business now. They're thinking, return on investment and effort and stuff like that. So it's
well, that leads me into the next question, which is in terms of these malware operations using DevOps principles to increase the scalability of attacks. And before Windigo, you were telling me the ESET team has never really seen these tactics used before. So tell us a bit more about that.
So on the traditional Windows malware, you usually have a couple of servers components, which we call command and control server, which are typically hosted on Linux. So you have a few to manage, and so the operators usually do it manually. Now in a threat like this, you have 25,000 infected machines. You cannot go on each server and then decide I will install the malware, this and that, I will look for the new users if I can steal more usernames and passwords. So it cannot be done manually. What needs to happen then is you need to scale. And the way they did it, and the way we noticed through the system that we monitored the bad guys with, is they're using code. So the code is sent directly to the server and reports back to the operator. And based on the output, he sends in more code specialized to do XYZ task. We noticed code used for reconnaissance. So before deploying the malware, they will gather a few specific things on the system. For example, is SLNX security enabled? Is a compiler installed and stuff like that. There's also code that we've noticed for deploying the malware. So the way to install it, it can leverage the Linux, usual package managers, or it can compile from source. And we also saw monitoring code, so code that will run every day on every machine to see were there new users created on the machine, and if so, do they have SSH keys we can steal, or to what system did they connect, so we can try also to connect with the stolen credentials that we've gathered so far.
Now, you were telling me a little bit of an arms race started up between Windigo's creators and ESET, when ESET was publishing information on how it was fighting the Windigo threat. So, and this is where you were announcing that you discovered something, and so how something worked, and the malware writers then read that and they changed how they were doing things. So clearly malware is constantly being updated, making it a real threat for end users. So tell us a bit more about how ESET and the malware guys are changing the traditional game of cat and mouse.
Yeah, so when we first published our report, they waited, like it took them a month maybe, I don't know, maybe to stumble on it or something like that.
They're probably surprised.
Yes, exactly. And maybe the code is outsourced. Maybe the one who operates it and the one who writes the malware is not the same person, and he was on vacation or stuff like that.
Who knows?
We don't know. But what we saw is that after a month or something, maybe they pushed an update which circumvented all the hints we gave to people to detect the malware on their systems without using an antivirus product. So we gave commands to put in to see if you were infected. And in the new update that they had a special message for us. they added a new string, so a new message, which said "Good job, ESET" inside this message. And so this was the point where we realized, okay, so now like they know, and now everything we will say, they will probably track and react to it. And so we kind of tested it, if you want, because after this point, whenever we published new indicators of compromise, they were worked around by the malware operators
pretty quickly.
The last update, I think it took a week, and we didn't do the update. It was one of our partner in this research, the German CERT Bund, and I think 1 week after that they quickly worked around, if you want. And in this specific case, it's only a name of a file that we were telling people to look for on the file system. But still, if it's the only way you can know if you're infected or not, without going into a big investigation or reverse engineering, it was still pretty helpful. So for us, what changed, as you originally asked, is we decided not to play this game anymore, and we asked people to reach us, send us an email, and we'll happily, once we've confirmed you are, really affected by this,
and not the bad guys pretending to want to.
Exactly. we received the odd emails that we didn't reply to so far. That's for sure. And so we've been then giving the hints, like this instead, how to clean it themselves. But in the end, what's best is to be trained and to reproduce what a researcher like me can do. And this is another big reason for the talk. Is inside during the presentation, I give the Linux command to be able to investigate. Okay, what processes created these sockets and stuff like that, to be able to try to fight yourself. And this is specific to the Linux malware, because you couldn't train every end users to understand the internals of their PCs. But Linux system administrator are already IT professionals, so we have kind of a unique opportunity here to have this dialogue with them and try to raise awareness of how to fight malware on Linux.
And there was something you wanted to mention about exploit kits and antivirus at this point.
Oh yeah, so part of the arms race, thank you for that, is for us what we've been also able to do proactively is to track the infection directly at the exploit kit level. Mm-hmm. So we block actively for the consumer of our products the exploit kit, and so they cannot be infected by these threats. And this has to be done manually. So we poke the infected servers and try to get where it's sending for the infection, and just blacklist whenever. To prevent the infection. Yeah. So this again is another arms race, because whenever they change on their side something, we need to do the same on our side.
So given what you've just told us, how else are cyber criminals managing to stay under the radar, infecting a limited but a steady number of victims?
So this is another change of behavior of theirs that they've did, is before it seems like they wanted more victims, and I think since they realized that they got attention, mm-hmm. they decided to scale down the operation while still having a good influx of revenue, I presume.
Yeah.
And so they've been limiting the number of infections. So a really behavior change, not a technological change, but a behavior change that they operated is they just want steady number of turnovers or whatever revenue
activations, whatever it is,
exactly, that they do. And so by doing this, they configure the servers differently. Mm-hmm. They try to limit the number of infection. The conditions to be infected are harder, so for researchers it's harder and harder to be able to trigger the redirection. And so at some point you don't even know if a site is infected or not, so it makes research a bit more difficult. And another thing that is really noteworthy that we notice regarding this kind of scaling down of mm-hmm. the operation is, so CDORG affects websites, and usually they infected servers that had websites that would draw a lot of users to them. But we've noticed that they switched gears in that they are now focused on porn sites. So they will make sure to be very present in porn sites. So porn sites still get them a lot of traffic, but we figure that they are doing so because no one ever reports back on a porn site that tried to show pop-up ads, pop-under ads, or try to send you to an exploit kit. You're not sure if it's on purpose or not, because you most of the time, I guess, haven't paid for the content. And so this is another thing that when we saw they were doing that, at first they were, why? They lose so many potential, revenue, but at the same point, like, okay, so whoever reports to a porn site that, it gave it a malware? No one. So I think that's the reason why.
They're very clever, those guys. So what are the steps, getting back into something a bit more serious, what are the steps that can be taken to detect and to prevent server-side infections?
So for detection, it's really, using standard command line Linux utilities. Mm-hmm. You can do the investigation yourself. And this is something I won't spoil because it's in my talk, which will be in video form later. Mm-hmm. So I suggest if you want the technical stuff, you watch that video. And also the snort rules, so the IDS, so intrusion detection system rules that we released as part of our report, I'm pretty sure still work because they are independent of the system and they haven't changed their protocol. So this is also a good place to look. And of course, antivirus products are updated to detect these pieces of malware.
Naturally, ESET can help in that regard.
Yes.
And if a company is infected, how do they recover from the situation? Can you just run some software and have it magically clean the system, or does it require a complete reinstallation?
So what we've been saying to people is, at some point, you need to realize if this malware was installed on your system, it means that they had super user privileges on your system.
Yeah.
So after this, even if, let's say, they didn't do anything, they could have done it. And this also means rootkit, so really low level, almost hardware level attacks.
Yeah.
So what we say is, don't try to be a hero and find the malware. Just wipe everything, reinstall everything from scratch from trusted sources, restore from backups.
Yeah.
And the important thing afterwards is, do not put back the same credentials as there was before. You need to be really careful about all of this, because one reused credential, one reused SSH keys means you will be reinfected. And we saw a lot of companies and people making that mistake. For example, let's say your enterprises uses an SSH gateway box.
Yeah.
So a server in between your server farm as a matter of auditing or whatever.
Yeah.
And if you reinstall through that server, but this server that you are reinstalling through is compromised, then it's of no use, because the credential will have been stolen again from that server. So this is another example of stuff we saw, is that they were trying to reinstall the correct way, but in the chain going to the new machine, there was another infected component, which rendered this useless.
And in the age of bad BIOS and the Thunderbolt attacks on Mac machines, where people have got devices plugging in that's rewriting firmware, I mean, does it also mean people have to check their firmware on their servers and reflash them and that sort of thing, or is that?
So luckily, servers tend to be locked into data centers with restrained physical access.
Yeah.
So like hardware level attacks like that are not
is easily
usual.
done. Yeah.
But that said, the Linux kernel still uploads firmware into the components. So PCI firmware for network and stuff like that. So it's definitely possible, but we never saw such a threat. So I guess what that means is that we should look for them, but I wouldn't be concerned about the crimeware. Like this whole operation is really a criminal activity.
Yeah.
I wouldn't be worried about them doing this type of stuff, but more about state-sponsored entities doing this. And then this is another different way of operation. It would be less large and more targeted, and so. But yeah, one should definitely be on the lookout for stuff like that, especially if you consider your organization, you consider it a potential target from the politics in United States or stuff like that.
Yeah.
But for Windigo, this is I don't think they will ever get into
that level.
Yeah.
So. Do you have any final messages for iTWire readers and also for your current and potential customers?
Yeah. One thing maybe I wanted to say is, like, we talked about detection, we talked about reinstall, but we didn't talk about prevention.
Yes.
So one thing that is very we need to share about prevention is that this whole thing is possible because the OpenSSH backdoor stole username and passwords.
Yeah.
So if you are able to prevent this step from happening, then you wouldn't be infected. And so one of the easy way to do it, but that could be wrongly done, is by using SSH keys. So if you use SSH keys, you really reduce your surface of attack, because SSH key is kind of like a fixed password of a very, very lengthy password, which is usually automatically generated by your computer. The way you can get wrong SSH keys is if you start hosting the private keys on the servers, then they can be stolen. And Windigo has all the capabilities to do that, to steal private keys from servers. So when thinking about this problem, we said, okay, so if private keys isn't good enough, SSH private keys isn't good enough, what could prevent them from spreading, knowing that it's all about stolen credentials? And this is where two-factor authentication comes into play. So right now, a lot of people, a lot of IT pros have two-factor authentication for their Facebook, for their Gmail,
yeah.
for their Twitter account,
yeah.
but almost no one has two-factor authentication enabled for a server. So this is, again, you know, something that is weird, because a server is a very important asset for your company,
yeah.
and it could easily be company policy to deploy two-factor authentication in order to authenticate. And the reason why two-factor would completely prevent this from happening is that on Linux, the way two-factor authentication is implemented is you put in your password and then you put in your code, which is either time-based or counter-based.
Yeah.
But in any case, every attempt means this code or time means this code is different. The little, you know, the 6 digits.
Yeah.
And so when an operator like Windigo stole credential, it has a very little window of opportunity to connect to the system successfully, which in the way they currently operate would not work, because they accumulate credentials for 5 minutes and then aggregate them onto servers. And so this means that even if they stolen the password, they wouldn't have the correct token to be able to connect in.
Yeah.
And so this is why when we were thinking about this in prevention, we were realizing that our defenses were not as high for servers than as high for our Gmail or Facebook, which for me made little sense, but it's a burden. It's not as easy to install as activating it on Gmail. So maybe this is something for the system integrators like Ubuntu or Red Hat to work on, or make, you know, more usable to enable. So yeah, that would be the one thing I would recommend, you know, everyone is prevention would be easy if you could do at least two-factor authentication.
Sure. And I'm sure this will be something you'll be also saying at the conference.
Yes, it will be.
Yeah.
Most definitely.
Okay, Olivier, well, thank you very much and good luck at the conference.
Thanks.